In the first lesson, we'll learn the basics, namely the data flow which defines our programs in LabVIEW. You'll learn about the user interface window and the window where you write the code. I'll also show you 3 important shortcuts. So, let's write our first program in LabVIEW. For that, we need to open LabVIEW. You'll see the main window. It has some options like create project examples and so many others. But don't get distracted. By the end of the course, we'll get to all of that. For now, allow me to guide you through the first program and explain what's most important for today. To create a new program, go to File, New VI, or use Ctrl+N shortcut on your keyboard. 2 windows immediately pop up. The gray one is the front panel window. This is the window for user interface, where you interact with your code. The white window is the block diagram window. Here you write the program. A good habit is to save program at the very beginning. Let's save it as Lesson 1, First Program. Programs written in LabVIEW are called VIs and have this VI extension. It means virtual instruments. As an example, let's write a program that calculates something and displays the result. Let's take an area of a triangle. On the front panel window, you can build a user interface using any of graphical elements located on the Controls palette. The Controls palette can be called from right-click on the panel or from the menu. So, right-click. Then, you can pin this palette to make it visible with the panel. The palette you see may be a bit different than mine. You can change the default view of the palette here. Customize Options. And then, in Palette, select Icons and Text. This view is quite useful for beginners because you see both the icon and the function name. That will help you remember better the location of functions. I always use this icon and text style. On the palette, you have a huge variety of controls. It may look like it's a lot, but don't worry. You'll get familiar with all of them in no time. Now, let's use some simple graphical elements from Decoration palette to draw a triangle. Simply click on the triangle, then click the mouse on the front panel to place and adjust it. Next, we need 2 controls for the basis length and height. The control allows to change values. You should also give controls a meaningful label. Let's show the result on the indicator. Note that inside numeric elements, we have plenty of different representations like sliders and kneaders. You may notice some of them are controls, which are data sourced to the program, and some are indicators, which display results of our calculations. Properties of this meter here can be changed with a context menu from right mouse button. Here you have a quick access to few mostly used options, and in the bottom you can choose all properties. All controls and indicators have those context menu options. Okay, we have this simple user interface placed on the front panel. Let's write the program that calculates the area of this triangle. To write the code, we go to the block diagram window by pressing the Ctrl+E shortcut. This is one of the most frequently used shortcuts, so please remember it. Ctrl+E switches between front panel and block diagram. Here on the diagram, you can see those 3 elements placed on the interface. You can, of course, move them freely on the diagram. To calculate the area of a triangle, we need to use functions, like multiplication. You can access functions through the Functions palette. The palette is available from the menu, but it is faster to call it by right-click on the diagram window. For better access, I would suggest pinning it to the window. On the palette, you can see a huge variety of different functions which you may find overwhelming at first. There are over 1,000 different functions available, and of course you don't need to know all of them. All the important ones you'll learn soon. You can change the view of the palette here. Customize, view this palette as Icons and Text. I recommend this view due to its clearness, because when you choose the function, you can see its name too. During this course, you will use this programming palette most of the time. Let's start with something simple, multiply. It's the function for numeric operations. So let's go to Numeric and choose Multiply. It's easy to spot due to a little icon, so Let's click Press and Release on this function. It's selected now. Then place it on the diagram. When it's placed, we can connect our numbers to its inputs. When I make the connection, I click here on Terminal, and then I click here on the other terminal. Again, click here with Release, and then here with Release. To obtain a triangle area, I divide this multiplication by 2. To do that, go to Numeric and choose Divide. Then, place it on the diagram. Now, click on Multiply's terminal output, then click on the input terminal of Divide. The second parameter is a constant number, 2. The easiest way to place constant value on the diagram is to right-click on the terminal and choose Create Constant. Then, the constant value is placed and connected. Now you can write the number you want. Now you can make the connection of the calculated result to the indicator. You can also choose a constant from the numeric palette. The program is finished. Let's check if it works. Go to the front panel with Control-E, or sometimes it's easier just to double-click on any control or indicator to be directed to the front panel where the certain corresponding element gets selected. On the upper part of both windows, you see a toolbar. You will learn about every button soon, but for now, let's start with just 2 of them. The Run button allows you to run the program. I'll set numbers 3 and 4. When I click the Run, you see the result is 6 as expected. You can also click on Run continuously. Then you can change values and see the result simultaneously. You can adjust the scale range to better display of the result. Now let's look back on the program code. You've already noticed that by connecting elements with those wires, you define the order of those functions' execution. Each function executes when the data is valid at its input. The order of function execution is driven by the data flow. Understanding this data flow mechanism is a main goal of this first lesson. One of the debugging tools is the highlight execution. Notice, when I press this button and run the program with the diagram window on top, now you can observe how the data flows through the wire. Let's add something to our code. Let's calculate the area of a circle with a given radius. We do it in a similar way. I'll draw the circle and place a radius value as a slider. The area will be visible on the indicator. Now let's switch to the diagram window with Control-E. Having the radius, I calculate its square and then multiply by pi, which is a constant. I can also choose it from the numeric palette from constants. Now program is ready to run, so let's check it. You can easily adjust the range of the scale by changing the maximum number. Let's run it continuously. Works as predicted. Let's study this program just a little bit more. We calculate 2 independent areas, triangle and circle, in 2 separate places. Can you tell which result calculates first? Actually, we don't know. Or, more precisely, we don't care. Those 2 results are totally independent of each other, so the data flow doesn't enforce any order of execution between those 2 parts of code. When one calculation is not dependent on the other, then we write it separately. Of course, we don't know which function executes first. But we don't need to care, and that's just beautiful. If the computer running this code had multiple processors, these 2 pieces of code could run on different processors, without any additional coding. This powerful data flow concept will be used all the time. Let's try another modification to our code. Let's check if the area of the triangle is bigger than the area of the square. On the function palette, you'll find Comparison, and then Greater Function. Let's place it on the diagram and wire these 2 values of triangle and circle areas to the function. Now the question is, what does this function actually do? To answer that, let's use the 3rd shortcut you should learn today, Control-H. It shows you the Context Help window. Context Help window shows you information about an item laying below your mouse cursor. This window is very helpful, especially at the beginning, and you cannot overuse it. so please for this course try to have it opened. You can also press this little question mark here. Let's right-click on the function output. Choose Create Indicator. Note here that the name of the indicator is selected, marked in black, and ready to change. I'll name it Is Triangle Greater? You can see that the color of the wire is green. We'll talk more about meaning of colors in the second example. On the front panel, you see a green diode which shows you Boolean values of true or false. When you run the program, you see that the value is shown properly. That is plenty for first lesson. With this knowledge, try to practice, do the exercises, and compare with solutions. Let me finish with a small sneak peek on one of the use cases of the while loop. You've learned already that the program can be run just once by clicking the Run button, or it can be run continuously with this Run Continuously button. Note that this Run Continuously button is only good for debugging, and generally, you shouldn't use it. So, to get your program run continuously after pressing Run button, or Ctrl-R, you need to place your code inside the while loop. I will explain this loop in details in following lessons. For now, let me show you just a simple use case for continuous operation. I navigate to Structures, While Loop, and I place it on a diagram. This is a graphical representation of the while loop. Right-click here and choose Create Control. The loop will execute everything that's inside its boundaries one time after another until the stop condition is met. In the front panel, I will move the Stop button, enlarge it, and turn off the label. Now when I run the program with a Run button, the program will run until I press the Stop button. Then it stops.